Hey guys, today we're going to start talking a little bit more about what it means to have sine and cosine on that axis, that xy plane, and we're going to put it in terms of something called the unit circle. So step one, go ahead and find the following trig ratios. We're looking at sine 60, sine 120, sine 240, and sine 300. This is something you can do on your calculator, but don't forget to make sure your calculator is in degree mode, since these are given in degrees. So when you put these in your calculator, you find that the sine of 60 degrees is 0.866, or that's really, and that's rounded, but that's actually radical 3 divided by 2, right? Yeah, because it's that special rate triangle, so I'm just going to remind us, but I don't mind if we have the calculator rounding for this lesson. Sine 120 is also 0.866. Sine 240 degrees is negative 0.866, and sine of 300 degrees is negative 0.866. And there is a reason that those four angles in particular all share the same sign, and we're going to start talking about that today, and we're going to introduce a new vocabulary term, and that word is reference angles. And the reference angle is the measure you get when you measure the number of degrees from the terminal side of any angle to its nearest x-axis. So if we look at 60 degrees, which is that first angle that we found the sine of, it's its own reference angle because the closest x-axis to that terminal ray is right here, and so we're just taking the measure from the initial ray to the terminal ray. But if we look at that second angle we looked at, 120 degrees, it's now closer to the x-axis on the other side. And if we wanted to calculate this, we'd say, okay, the straight line across the x-axis here, that's 180 degrees. 120 of it goes to here. So the remainder here must be 180 minus 120. And we've got a reference angle of 60 degrees. And then the third angle that we looked at was the 240 degrees. Now it's closer to this x-axis again, but it's on the other side of it. So this entire marked arc is 240 degrees. And we're just looking at this particular piece of it. So we're cutting out the other 180 degrees of it. And that angle, that reference angle, is also 60 degrees. And then, yeah, same thing for 300, or I've got 315 degrees in my diagram here. 315 degrees would be closest to this x-axis, but it's coming up from the other side. So we're just looking at this piece here. A full circle is 360. And then if we take out that 315, we're left with 45 degrees as this piece that is our reference angle. So when we calculate a reference angle, we're either adding or subtracting to find the distance between the terminal ray and the closest x-axis. So quick check-in, what is the reference angle of negative 111 degrees? So we're just looking to see where the closest x-axis is, and it's the negative axis to the x-axis to the left here. And then we're measuring from the terminal ray to that axis. So we want that chunk right there. And this whole angle across the x-axis is 180. So we're doing 180 minus 111. I know that this 111 is negative, so we might be saying, why aren't we doing minus negative 11? We're talking now about absolute values. We're not worried about the negative or positive. We're just looking at the distance here, and distance is always a positive measure. So this distance from this terminal ray to the x-axis is going to be 69 degrees. So the reference angle is positive 69 degrees, even though if we're going clockwise around the axes, we know that that means that we're looking at negative angles in terms of direction. So reference angles are always positive. This isn't a do know anymore. So the circle below has a radius of 1. Angle theta has a terminal ray that crosses the circle at 0.8.6. Find sine of theta, cosine of theta, and tangent of theta. Let's do one of these together because it's a bit tricky, and then you guys are going to find cosine of theta and tangent of theta on your own. So we have here, can I zoom in a little? Okay, we're zoomed in. So angle theta has this terminal ray. We're looking at this angle, which is labeled angle theta, and it has a terminal ray that crosses this circle at the point 0.8, 0.6, and we were told that this circle has a radius of 1, which means that this line, the hypotenuse of the triangle we're going to make, is 1. So then I'm just going to draw down to the closest x-axis and create a right triangle here. And I can find the length of these two sides because I know this point is 0.8.6, which tells me that the distance I've gone along the x-axis here is 0.8, and the distance that I've gone up the y-axis here is 0.6. So I know I have a triangle that goes 0.8 on that side, 0.6 is the length of that side, and 1 is the length of that side. And so if I'm finding the sine of theta, and my angle theta is this angle, sine is always equal to opposite over hypotenuse. So the opposite here is the side opposite of theta is 0.6 over my hypotenuse, which is 1, and 0.6 divided by 1 is just 0.6. So the sine of theta is 0.6. Go ahead and find cosine of theta and tangent of theta on your own. All right, so cosine is going to be adjacent over hypotenuse, so it's going to be 0.8 over 1, which is just 0.8. And then tangent of theta is going to be opposite over adjacent. So it's going to be 0.6 over 0.8, which if we asked our calculator to simplify it for us, should be 3/4 or 0.75. But I'm happy for you to leave it like that, honestly. All right, do you notice anything about those sine, cosine, tangent values when we look back to this point? Turns out this sine is just the y value of that coordinate, right? And this cosine is just the x value of that coordinate. So let's do this a little bit more generally. So this circle that's shown in the diagram here is called the unit circle. And why do you think it's called the unit circle? It's a unit circle because the radius of the circle is 1 unit. And the reason that that's important is that that means that anywhere that we draw a point on this circle, if we create the angle at that point, the reference angle, and draw down, we're going to have a triangle that has a hypotenuse of 1 anywhere on this circle. So let's use this circle to find an expression for sine of theta at the which using this triangle, which is created by theta's terminal ray hitting the circle at the point x, y. So that means that if I draw down here, I have a triangle which has a side of length x, a side of length y, and a hypotenuse of 1. So if we're finding the sine of theta on the unit circle, we can say that sine is opposite over hypotenuse. The opposite side of theta is y units long. The hypotenuse is 1, so sine is equal to y. And then cosine of theta, if we're looking on the unit circle, our adjacent side is just x, whatever x is, over the hypotenuse, which is 1. And so cosine of theta is x. And then tangent of theta is equal to opposite over adjacent. So the opposite side is x over the adjacent side is y. Which, didn't we just say that sine is y and cosine is x? Wait, what did I do? Y over x. My bad, guys. That's embarrassing. Y over x. So tangent equals y over x, which we could also write as tangent equals sine divided by cosine, which is a proof that we did in the last video, right? So now you've proved it twice. But you can also just think of it as y over x, because this is the point of the unit circle, and this is what makes it useful. If we draw our angles onto the unit circle and we know the coordinate where we hit that circle that has that radius of 1, then sine is just going to be the y-coordinate of where our terminal ray hits that circle. And cosine is just going to be the x-coordinate of where our terminal ray hits that circle. And tangent is just going to be the y-coordinate over the x-coordinate of the point where our terminal ray hits that unit circle. So that's what's useful about the unit circle, and that's really what's useful about putting our angles on an xy axis. So back to reference angles, we just, actually, you know what, we're at 11 minutes. I'm going to cut us here, and that's what the unit circle is. We're going to do some practice with that, and I think in tomorrow's video, we'll go back to what it means to think about reference angles on the unit circle, and we'll use that to explain why you got these 4 values you did that are the same number but some positive, some negative when we did the do now. All right, guys, try the delta math. Have fun. Talk to you soon.